So good morning, guys. So today we are going to study transformer modeling for equivalent circuit. Very important topic as far as state point of view. From this, you can get many questions regarding equivalent circuit, voltage regulation. Let us see transformer for equivalent. So Sunil Manjani was something about me. You know, name Sunil Manjani. I got 18 plus years of experience. MTech from VNIT Nagpur, VNIT Nagpur. I've cleared exams like GATE, exams cleared like GATE, final selections like Discom, Genco, Gen that. These are my final selections. Also, on aeronautics. So these are some of my achievements. Something about me. Okay, let us move on to our topic. That is transformer model. A transformer consists of two parts. First part is called as core. So transformer consists of two parts. First part is called as core. So core, you can see that is just like a closed former. Okay, the 3D diagram for core. Just like a closed former. Core is made up of iron material. If I may say particular, that is silicon steel. Silicon steel, and it is laminated structure. Okay. Each lamination is of thickness of each of 0.35 mm. Okay. Silicon, the steel is around 3%. Steel is for producing the flux, that is for magnetizing the circuit, and silicon to give the mechanic. We are achieving both. On this core, we have what winding. First part is core, second part is winding. Second part is winding. Second part is This is your winding where supply is connected. This is called as primary winding. This is your winding where you connect a load called as secondary winding. Okay. Now winding, we want to model these two parts, that is core and winding. We want to model these parts, core and winding. First of all, we see winding modeling. The main function of winding is to carry current. Carry current. Okay. So to carry the current, you need to have some resistance on this, isn't it? We have supplied some voltage, therefore there some resistance, so it carries the current. Also, this winding, when it is wound on a former, whenever we know that whenever a current flows in a winding, there is a flux produced around it. So there is a flux link. Flux linking is like a simple modeling of the transformer winding is like this. R is a circuit. So this winding, one uh, one more thing I need to tell you, that it is made up of copper. Simple winding model is RL circuit. Okay. So this is simple winding model. Next, we need to see what is transformer model. Transformer core mode. Core mode. Okay. So what is core modeling here? We need. So how to model a core? How to model a? So let us see. Now core. Before that, we need to see how, what is the operation of transformer. As soon as we apply voltage, current I1 will flow to the primary winding. This will cause a clockwise flux in the transformer core. This flux is alternating. This flux is alternating. Okay. So it will have rate of change of flux. Rate of change of flux will link with both the coils. This primary winding and secondary winding will generate an EMF one in generate EMF E2 in the E1 is equal to magnitude wise minus, sorry, N1 d phi by E2 equal to by N1 is number of turns primary turns. N2 is secondary. Okay. N2 is secondary. So we have got this type of EMF induced in the primary and secondary winding. Also, there is primary winding will behave as a source of flux. How? Current I1 is flowing in N1 number of turns. So we will have primary MMF generated as 1. This will behave as a flux source. This will behave as a flux source, and it will emanate flux from the primary part, and that flux will flow through whole core and also link with the second. Link not only with primary but link with the second. Now here important part is this flux is flowing through the core. What does flux causes? What does flux causes? Okay. Let us see. Okay. So let us see. Okay. Let us see flux. So flux will be alternating flux. Now this alternating flux will have positive cycle and negative. So this flux will have positive cycle and like alternating current. So magnetizing force, which is a current, causes flux. This flux uh, causes flux. Okay. So magnetizing force we can represent it by H. Will have alternating cycle. First H will is plot BH curve, and then if H is going to negative direction, it will not follow the same path but other path, and in negative direction it will again first H increases, B increases. After that H decreases, B decreases in a another fashion. Okay. So during the negative cycle, you can see that when H is 0, B is B residue. B is B residue. Okay. To make B 0, we need to have H at some negative side also. Okay. Negative H also. This is called as coercive force. Negative HC called as coercive force. And flux is called as residual. When H is 0, residual flux is. So at start, at positive H is proportional to B, and during negative, during reverse action of S, reverse H, when H equal to 0, B is not equal to 0 but equal to B. When H equal to minus H, that means in negative direction, when B is 0, H equal to minus. So B lacks H. B lacks H by this is called as his, and this produces the transformer. Okay, type of loss. Next, okay, next we can say that next we can say that whenever in a core a flux is flowing, mostly core is laminated. Okay, sometimes what happens that it will find a closed path inside the core. This closed path inside the core causes some current flowing through it because flux is alternating. Okay, so this current causes circulating current. This current is circulating. These currents are known as eddy current, and this produces heat in a transformer. These are also counted as. So there are two types of losses in transformer. One is eddy current loss. Other is all this due to alternating. alternating. So losses are produced due to the flux. So one thing we have learned, losses are produced due to the flux. Second, flux also links, also flows in the, that means core gate mag, core gates. Whenever I am saying magnetized, that means it is a active phenomena, active phenomena. Okay. So core flux will have two functions. First, to magnetize the circuit. Second, to produce core loss. Core losses are byproduct. So flux will have magnetization function, thus it will produce. Okay. These are two main, you can say one function is for magnetizing and other it also produces losses. How you model this? Whenever I'm saying losses, these are heat losses. This is the real component is resistance. Magnetizing is, so flux will produce inductive effect as well as resistance. How you take into account? To take into account by drawing a parallel circuit, two parts. One is R0, okay. Another is X0 is 2 pi F into, this gives you total losses in core, and this give magnetization effect. This gives magnetization. Okay. So in all we have seen how to model the transformer parts. Okay, now we'll see complete transformer modeling. Transformer modeling. So let us see. First of all, primary is there. Primary winding is modeled by RP and X in series. Then we have got core. Core is modeled by R0 and X0. Then we have got primary winding itself. Not modeling, just drawing the diagram. Core representation by a parallel line. Another representation of secondary winding. Then we got component. Then we got a load. This is supply. Okay. So this is supply and this is current I1. So this current flowing in this branch is called as no load current I0. This current is I dash. EMF induced in primary winding 1. EMF induced in this current is I2. Okay. Also I. That is load. So in this way we can get complete transformer. This we can further reduce to find out voltage regulation, efficiency, transfer. So in this way, we complete the transfer modeling today. Thank you very much. Thanks a lot. We'll come up with other topics in near.